my talk is front-end apps tooling. I'm Nico. I'm Bevacqua on GitHub, and I have a blog, like he said. And I've always kind of been obsessed with builds and automating stuff. So that's kind of the purpose of this talk. I'm pretty much done writing the book he mentioned. It's mostly focused on processes, but applied to JavaScript and how to design applications that are built first. So the user app, for instance, a linting process, so that you kind of go along checking the quality in your code as long as you're developing the application itself. I also talk about modularity in your application and how to compartmentalize the different pieces that make up your app. I obviously talk a little about testing and, in particular, testing in JavaScript and also a few lesser-known types of testing, like visual testing, for instance, where you take photographs of your site and compare them. And it has a lot of code samples that, even if you're not going to buy the book, you should check those out because they are open source, and I took the time to document every one of them. So I guess, to me, they're worth looking at. If you're interested, here's a discount code that you can use to get it cheaper. So anyways, the talk is mainly going to focus on why you should actually be building and the different improvements in your development flow that you'll get as a result, how you're going to be building and which tools you'll be using, and what kind of tasks you're able to perform using these build tools. And lastly, I'm also going to touch a little bit on modularity, and in particular, modularity in the browser, and not just in Node.js. So why build? And why build first? And the main reason for that, and don't get me wrong, it's not just building like, OK, I'll set up the whole build process and I'll make a deployment script before I even write my first div. Right? It's more about making it progressive and building out your build processes as you're building your application. So that way, your application won't become a thing that you pretty much have to build out by hand, and then you have to create a lot of hacks to kind of sort out the issues that you have when you're trying to optimize the site for production, right? So there's three main reasons why you should be building first, and kind of the reasons are pretty much the benefits that you get out of it. And these are process, productivity, and performance. And I'll go through these one by one. So process really means automation, being able to write one thing once, get it right, forget about it, and have that process be able to run every single time and have the exact same output. So this really means that it eliminates repetitive work so that you're able to, and that doesn't just apply to, OK, I'll build for release and I'll deploy once a month or something. But it's more about the little stuff, like linting every time you save a file. Why don't automate that and get rid of it? And the other important part about automation is that it reduces human error. And there's this story I like to tell where a company known as the Knights Capital something, operated in the New York Stock Exchange. And they were working with money, right? So everything they did was money. They either earned money or they lost money. But there was nothing else in between. And they had this awesome deployment process where they had one guy handling deployments by hand over 7 different production instances. And this one time, he just forgot that one of the instances, so he deployed to the other 6. But the slight issue was that the deployment contained a replacement for an old piece of code behind the flag that was turned off 10 years ago. And then they turned on that flag on the database. But the 7th machine had the old code. So long story short, they started losing money. And they figured, OK, the issue must be in the new deployment. So they started rolling back the deployments. And then they had 2 machines with the old code. And they started losing money faster. So they were like, oh my God, we have to act faster. So they started rolling back more and more environments, losing more and more money. In the end, I think they lost about $500 million in half an hour. And they pretty much went bankrupt as a result. So if they had an automated deployment process in place, that wouldn't have happened. Or at least they would have been able to quickly identify the issue and log that the error where they didn't deploy to this 7th machine, and they wouldn't have went bankrupt. So like I said, it reduces human error and eliminates repetitive work. Automation. Automation also means being productive. And not just being productive during deployments, but also on your day-to-day work. So productivity is pretty much attained when you have a continuous development process in place. And by continuous development, I mean being able to run your tests or lint or rebuild anything that you need to rebuild, like pre-process your less styles every time you save a file. And maybe you go even further than that and have an extension on Chrome, for instance, that's like library load or browser sync. How many of you have actually used something like that? OK, a few. So those extensions, what they do is basically when they detect a change in your file system, they use typically WebSockets to inject those style changes or JavaScript changes. And I'm pretty sure browser sync by now or in the next couple of months will support HTML injection as well. So being able to automate your saves, automate your browser refreshes, and being able to automate your build processes pretty much means that you're just typing code and alt-tab into the browser, and you see things in real time. And there's not many hacks involved in doing that. And it's easier than it sounds. And then there's continuous integration, which really is taking the same concepts that you had in doing continuous development and applying them to the quality of your builds so that you're able to take what you had in your local environment and test it in the cloud, like some of the speakers like to call it. And then you're also able to, once you have the continuous integration in place where every time you push to your BCS you get a build running on a service, and that service lets you know if the build blew up or actually worked. And once you have that, you are able to do continuous deployments, which aren't always as catastrophic as some people make them out to be. If you have a continuous integration system in place where you can test your build every time you produce a new change, you're kind of safe there in that if something goes wrong, you just won't deploy it. So if you set that up with, and it's really easy with these platform as a service providers that we have today, and it's not something you had maybe 10 years ago. So it's something worth looking out for. And then there's also performance, right? You're able to compile your assets, bundle them, minify them, sprites, and hash them so that you can set up expires headers in the far future. This means faster response times and hyperhumans, which is pretty much what we all want, right? So what tools can you use to automate your processes and to do these continuous everything kind of flows? Well, a while ago, you pretty much had make and right? And that was pretty much it. But today, we have these really awesome tools that are maybe more fit for web developers because they're more closer to our hearts with JavaScript in them and whatnot. So you have NPM, for instance, which is not only a package management system, but you can actually use it to run your builds as well. And I'll talk a bit about that later on. And then you have Grunt, which I'm pretty sure most of you are quite familiar with. And there's also Gulp, right, that came out a while ago, and it's pretty good too. And then there's Yaman, which allows you to quickly create new templates of an application and remove the parts that you don't want. And there's also Branch, which allows you to do some other build stuff. And there's, I think that's Fez, and Broccoli, and Amble something with a flame in it. I don't even know. Yeah. Anyways, I'll focus on those three for now. But really, my point is that there are so many tools that there isn't really a right one to use. So you kind of have to figure out on your own which tools you are most comfortable with and use that instead of trying to figure out which is the absolute best tool for every use case, because there is no such thing. So let's start with Grunt. Grunt is a configuration-driven build tool written in JavaScript that it's pretty much very easy to configure. You just put together a few different JavaScript properties, maybe a few functions, and you're done. It has thousands of plugins that you can use to do any sort of thing, from linting to building to deploying to wherever you want. And it's just JavaScript. You're also able to create your own plugins really, really easily. And they entail really little knowledge of the actual build tool, because you just have to do like Grunt register task, a name and a function, and you are able to do it asynchronously too. The issue with Grunt is that long build flows tend to get too verbose, right? And unless you're configuring each different task in different files, it gets kind of messy, right? And the problem is that even if you do that, it's kind of blurry, because the different tasks are really the plugin names. And maybe you have like a a CSS debug task and a CSS release task, and you have to configure them pretty much in the same place, and they don't really have a relationship that's reasonable, because yes, they are the same kind of tool of task, but they're not part of the same flow where you build everything for debug mode for local development, and then you build everything for release, where you optimize stuff rather than create debugging symbols. And it's not so fast. I mean, there are faster options out there. I think pretty much all of us know that. So Grunt is pretty easy to install. You just do npm init, lay out your package JSON. You install the Grunt CLI globally, which will just look up the local instance of Grunt so that you can use it to run your builds. And let's look at an example of how we can use Grunt very quickly. You have to set up a Grunt file in addition to installing all of that. And in the Grunt file, you write CommonJS code, which some of you may or not be. How many of you do know what CommonJS is? OK. So CommonJS basically lets you write files, and every file is a module. And if you're doing module export SQLs, that means that that module will export this API. In this case, it's a function that takes in Grunt. And what Grunt will do is they'll load up your module, which is your Grunt file, and pass in the Grunt variable, and you're able to configure Grunt using that. But we'll talk about CommonJS a bit later. For now, let's just focus on the function. So you load the Grunt spritesheets plugin, which is basically something someone else developed to make creating spritesheets really, really easy. So you initialize the configuration. You name the task that you want to configure. You set up a target, like debug release that I mentioned earlier. You pass in a few options, like where your images are, where you want the spritesheet and the styles to be in, and you're done. You run Grunt Sprite, great. And that's pretty much what you get out of it. You have 4 different icons, and you get one single icon back, and the whole styles. It's not actually all of that, but it's a part. It's somewhere in there. But anyways, and you can do much more complicated stuff than that with Grunt too. How many of you have used a platform as a service provider? Yeah, pretty much all of you, right? So Amazon EC2 is basically the backbone of that. They have the infrastructure, but you have to pretty much do everything on your own. You have to launch your own instances, and you have to configure everything, run apt-get, and install a lot of stuff. And then once you have everything set up, you're finally able to deploy your application code. But you can also use a Grunt task for that. You just configure Grunt, set up an access key, a secret key, or security group, and boom, you just build your application out, install a few things, compile your spritesheets, create a changelog, run your tests, and once you have all of that, you'll be able to deploy. So it's not just about building and optimizing, but you can also automate your deployment processes right within Grunt. So I'll save you the pain of going through the whole video, which I think is like 3 minutes long, and we'll move on instead. So then there's gulp. Gulp is code-driven rather than configuration-driven. And this means that you're just writing out a code in a bit more organized way than with Grunt, which is just a manifest. So it's leaner than Grunt in that regard. it has hundreds of plugins because it's not as old or popular as Grunt is. It's just JavaScript still, but it's kind of harder to work with if you're not really used with, to develop things with Node, or you don't really understand the concept of streams, pipes, and asynchronous code very well. And that's something that Node really makes you work hard to understand. But if you're not really developing in Node, you don't have a real reason to learn all of that in JavaScript. So that's kind of a drawback to me of using gulp, because with Grunt, you're able to pretty much set a build process without really knowing anything about the kind of task that you want to perform. You just need to set up a few very different and concise properties of what you need, and you get the result you want anyways. But gulp is faster than Grunt. And that's because Grunt tasks start and end, and they read and write from the disk every time. And that's very I/O intense. Whereas gulp does everything pretty much in memory. And that's why that's thanks to using streams and pipes. So you're able to take a file, change it a little bit, and write it to disk again. Or maybe you, instead of writing to disk right away, you change it some more and you write to disk. So it's way faster that way. So to install gulp, you pretty much do the same thing as you did with Grunt. You install it globally, locally, you get a package JSON, and you start putting together a gulp file. The gulp file is still a CommonJS module. The required statement here basically means that you're importing gulp yourself rather than exporting a function and having gulp take care of it for you, like we did with Grunt. So you define a build task. And if you were to do gulp build, it would do nothing, but it would work. So you require some other plugin, Uglify. And you take your source code, you pipe it through the Uglify plugin, and you write to disk. And there you go. You have your minified module as a result. But maybe you also want to print the size to the screen of how big your module is after minification. You just pipe through size, and you get that. But you can also change the minified module to get a little header file that says like the license information, version number, package name, and maybe even a link to your site. And you do gulp build, and you get all of that. And then there's NPM, which is even leaner. It's script-driven, meaning that you pretty much are writing code in bash. And that may be kind of throw you off a little bit, but it's kind of a mixture between using make, for instance, and using some other tools like Grunt or gulp. And you're also able to run JavaScript build tasks using npm run. But you're mostly going to benefit from using a CLI, like instead of using Grunt JSHint, you're going to use JSHint under CLI. There's barely any configuration, as we will see in a bit, but you pretty much don't have to do anything. And the cool thing is that you can use any npm package that you want. You don't have to just use the plugins that are written for gulp or for Grunt or for Broccoli or whatever. You can just use any package that has a CLI for it. And like I said, it can be just JavaScript if you set the environment to Node. The issue with using bash is that it isn't so cross-platform, and you're going to run into issues with Windows. But that's OK, because if you need to support Windows, then you're probably better off using Grunt or gulp. And yeah, it's faster than the other two. So there's that. So like I said, there's no installation process in npm run. You just initialize the package.json manifest, and you set up the scripts property. And every key that you set in there is going to be run. And the cool part is that you don't really have to have every CLI installed globally, which is a misconception that I think most people that don't use npm run have, and that's that you can actually install succinct locally as a development dependency, and npm will be able to figure out, hey, they want the CLI that's in node modules, succinct, bin, wherever. So you do npm run length, and you get the linted file just like with Grunt or gulp. But the point really is that it doesn't matter which tool you use. What matters is that you are comfortable with it, that it does the job for you, and that it works for you. And the other thing that I wanted to discuss finally, modularity. And that brings me to npm. And npm has taught me so much about writing modular code, and even for the browser. And that's because I was able to take my gigantic JavaScript files that I was so used to and stuck in script tags, making sure that they were ordered in the right place, or maybe even using AMD, but having all of that boilerplate code that was wrapping all of my code. And even going through some other people's node modules, they were like really precise in what they did, and they had a public API that was very succinct. And in some cases, it was maybe a little extreme, but most of the time, they did exactly what they were supposed to, and not much else, which is a great thing. And we all should strive to try and create these small modules that do one thing very well that Unix kind of taught us to do. But we got lost along the way somewhere in the web. So how do we bring npm modules into the browser and actually be able to run them? And the answer is CommonJS. CommonJS plus, well, yeah, I guess it's not IE, but something, and browserify, which is this hat that I have in my slide. And using all of that, you're able to take the CommonJS modules, compile them for the browser, and just run them. So finally, CommonJS is, like I said, a module system where every file is a module. Modules have an implicit local scope, which is the great part. And this really means that if you declare something at the top of the scope, like bar foo outside of any closure or anything, it'll still be local to that module. And modules can expose a public API, like I showed earlier with module exports, and that can be an object, a function, or any literal chew. And they can require other modules in, like we've seen with gulp. And module loading is synchronous, and it happens in code. So it's not like AMD, where you kind of have to work through all of this asynchronous magic code and then compile it down to a bundle in production, which makes no sense. So as an example, but I guess we are already familiar with this, as we saw earlier, you just declare a piece of code where you have your variables that are local to your module. You export an API with a couple of methods, and then you are able to consume it really easily, passing the relative path to your module and using the API. So in Node, you would run that as node foo. Foo would get to the require statement, load pony.js, and just work. But that's Node. How do you yeah, I don't know. How do you even do that in the browser? It's not like you have a file system, right? So that's where browserify comes in. Browserify kind of inlines require calls, meaning that it'll compile the pointers to those files and load every module once and figure it out for you, and then it'll bundle everything together. It ports Node Core modules into the browser, so if you need something from the Node Core module system, like the util module, which allows you to do string formatting and some stuff like that, or the URL module, which allows you to parse URLs, or the query string module, you can use those in the browser without any issues too. And non-common.js modules can be shimmed. And this was a problem with AMD, right? If you remember a few years ago, this was really an issue because most libraries that you wanted to use didn't really use AMD or UMD or any module universal thing. And if you wanted something in AMD, you pretty much had to go to the library author and be like, hey, you need to support AMD. And they were like, no, I don't. And yeah, OK. Well, I want to use AMD then. So the other cool thing is that it has access to all of NPM. And this really means that you can use the same modules that are used in Node, but in the browser. And even modules that weren't really intended for use in the browser, like maybe Markdown parsers. And you are able to bring those to the browser, and they'll actually work, and they won't be as bloated as you may think. And browserify also generates source maps so that it's really easy to debug, too. It's not like it's going to have any issues in there. And like most things, it's a build step that you can automate away. And that's going to be it. So to compile something for the browser, you could take the npm run route, for instance, or you could use gulp and grunt too. But here I just decided to show you how to use it with npm run. And you use the browserify CLI, you pass in the foo module that we had earlier, and that will give you the compiled version that actually runs on the browser. And then you put it in a script tag, you run the build process, and voila, you have the common.js module that actually runs on the browser, which is pretty neat. And you get IE wearing a hat, which is quite nice too. So you're also able to share functionality, and that's another great part of using browserify. For instance, if on the server side you have some implementation that use the FS module, which allows you to read and write stuff from the file system, you don't really have access to that in the client side. So if you wanted to reuse something like that for the browser, you'd be pretty much fucked, right? But there's a solution to that. You could write a client-side implementation that pretty much takes the parts that use the file system and uses local storage instead. And that would be great. It will work pretty much like you want it to. But the problem is that you would have two different implementations. You would have the browser implementation, the Node implementation. It would be kind of hard to maintain if you were to point people at, OK, if you want to use it on the browser, use this, please. If not, use the other one. It's kind of messy. People wouldn't really use your stuff as much. But you're able to sort through that if you write some implementation that's kind of going to use different implementations for either the browser or the server. And so in this case, I'll just abstract away the file storage or persistence system, and then I'll write an implementation that's going to just use the local storage as a way to persist stuff. And then there's the file system version where you actually write stuff to disk. And then you pretty much say, OK, the store is going to be the file pile for my server-side implementation. And on the browser-side implementation, I'm going to use the local pile. Awesome, my module is great. OK. And you actually are able to define a browser property that allows browserify to say, hey, when I'm talking about the file pile module, you should actually use the other one. And this really means that when browserify is parsing through my require statements, when it finds the local pile.js statement, it's going to use the other one. And that means that it's going to be able to compile my server-side implementation into a client-side one. And I'll be able to not just recompile the whole thing, but just change the bits that are necessary to change for the browser. And in this case, I just wanted to change the service that persists data, right? So you get cross-platform ice piles. And that's pretty awesome. So as a recap, build first rather than later. You'll be able to increase your productivity so much. And eventually, you'll be able to get to the continuous integration and deployment parts, which are also pretty awesome. Make tools work for you rather than trying to cram your build processes into something that doesn't really fit your needs. Browserify all the things. Or try web components or something, but try and start writing modules. That's all I had. Thanks.